Hi everyone. It's week 9. This is the week right after spring break. So this was Friday, 3/25, and we started out the course. First thing we did a little review. We talked about the theory, and we went through some of those items. We talked about skills, the skills we're learning, and currently now we just finished up scripts, and we're talking about scheduling events in the computer. And we're going to add users on next week. We set up servers, so forth. So, other things we talked about after the review, we talked about assessment. There's a solution. You need to look through that in terms of looking at how you did on the last assessment. We moved into scheduling on the 25th. There will be some security things that will be tied in with the scheduling. We're working on chapters 13 through 16. Those are all on, so you can just keep working. Check Canvas for the schedules for those, and you continue to work on your theory outline. Towards the last 3 weeks, we will have some items that we'll do concerning the outline, discussion boards and so forth, drawing that information together. So then today we did this communication. We communicate between machines, security, but without a passphrase or key. So let's talk. Before we talk about that, actually, we talked about scheduling commands. So you can schedule a command. You can actually type the prompt at and give a time for the command to execute. There's a variety of ways you can do this. We just did the example in class of giving a particular time, like 8:50 or something. And then it gives you this array of things to do, and you can type in commands here that you want the computer to do. That would make sense to be run, so to speak, in the background. And then the end of task, actually, to stop that, you can do a Control-D. And then there are some things that you could type to take a look at those tasks that we'll cover here in a minute. The next thing we talked about was a cron. You can set a crontab. You can use a command to list the crontab, see what you have there, and then this command allows you to edit the crontab. Now, when you edit that crontab here, it's going to use the default editor, which is VI. Alright, so we have here then, there's 2 ways to do it. You got the at command, and you can create a crontab. Okay? When you do the at command, there is also a command that you can type ATQ, and that would allow you to view the jobs that you have started. And there's also ATRM that would remove the jobs that you have in the queue if you wanted to do that. Alright, so you can type, I'll repeat that again, ATQ, you can view the jobs, and ATRM, if you have some jobs in the queue ready to go, you can actually remove them if you want to. Now the crontab will run, once you create it, you can set it up so that you can set up which minute you want it to execute at, which hour of the day, which day of the month, which month of the year, or plus actually when, in terms of day of the week. You could have it go every Sunday, Monday, Tuesday, and so forth. This would be a Sunday, and this would be a Sunday. So we looked at some examples, and you would set up your crontab, you would fill these in and then have the command, which we used here, a script to execute. Alright, so there are some examples that we gave in class when we did this. Now, in order to get that crontab to run in the evening, we needed to set up communications between two devices. So we did some work on security. First thing we did was looked at some terms. So we talked about the key. You could have a pre-shared key or a public-private key pair. Pre-shared, you can set up a key on each end and then encrypt the data on one end and use the key on the other end to decrypt the same key. Or you can set up a public-private key pair. When you encrypt with one, you decrypt with the other. We'll talk more about that in a minute. We have encryption algorithms, for example, to encrypt. I gave a couple examples: advanced encryption system or triple DES. And then we talked about the other thing, hashing. You can hash text, becomes a fixed length. We have MD5, SHA. We use the hash to verify integrity. We encrypt usually to verify or to work with the confidentiality of the information. We did this example in class. So we did Chad has his public and private key, and then in this case Van, he has his public and private key. And then we talked about transferring a file from Van to Chad. Okay? To verify the file's integrity, we could hash the file, send the hash over. When Chad gets the file, he can hash it, compare the hashes, and if they're equal, the file didn't change. Now, how do we know if somebody didn't look at the file while it's being transferred? Well, we can encrypt the file on this end, send the file, decrypt it on this end. And so when we do that, we could use a pre-shared key. Key here, and key here, pre-shared. Now, if we can't do that and send a pre-shared key, well then we will do some things like use a key pair, public and private key pair. So what Chad can do, he can send his public key to Van. Van can use that key to do the encryption. Actually right here, I showed it up here. He can use that to do the encryption. Then the whole process continues. We send the file and it's encrypted now. When the file gets to Chad, Chad can use his private key to decrypt it. And so that'll work. Nobody can decrypt the file except Chad, because this is the only key pair that'll do that. Now if we want to verify, if Chad wants to make sure it came from Van, well, we can create sort of a digital signature. One way we can do that is we can have Van, if Van wants to verify this, Van can send his public key over to Chad, and then he can take his private key, which nobody else in the world has. He can take a hash and encrypt the hash using his private key and create what we refer to as a digital signature. He can send that over. Chad can take, he has Van's public key, so he can decrypt it. He can take the message and hash the message and then compare those two and see if they match. If they match, the sender must have been Van. Alright, we talked a little bit about Diffie-Hellman, and you can look more at that. We didn't go through the specifics of that at this point. We can later on. So then we said there is a way to set up this whole process between two Linux boxes. And we're going to use a pre-shared key. But first we're going to do is generate the key using a command. This will generate the key. and it'll also put it in a particular location. There are some information concerning how to do this in the outline. Okay, not the theory outline, the other outline we gave you in the introduction part of the course. You can double check that outline. Once you create the key, then you can copy the public key, kind of like what we're doing up here. You can copy that public key to a machine. And then, once you do that, this machine, going to the machine you copied it to, can now communicate without a password. More specifics on that are in the work that we did in class, plus in the outline, the skills outline for the course. Almost done here. Theory-wise, we talk about file systems. Okay, file system is a structure on a block device. It's a structure on a block device. Metadata, okay, metadata is a collection of attributes about the file. All right. We can support multiple file systems at the same time. Okay. Then we have this namespace that we look at in terms of file systems. Formats, file, FAT, we talk about FAT file system, FAT32, NTFS, ext4, CDs have a file format, maybe your camera has a file format. And so we can take and mount these file systems. And so the namespaces can actually involve more than one file system. You may be able to look at the folders or directories on a computer, and you can see that it's referencing a CD, or maybe it's referencing your camera, so you can download some files. Okay, actually, it's possible to reference different formats. All right, so then we talked about disk. This term is used in a couple different ways. Most typically, it's thought of non-volatile, and we think about a disk block, a sector. Now, a lot of times we think about this being a platter. You divide it up into sectors, and then we have our tracks going through there. Then we have a cluster of information, so we have the tracks. You can partition a disk. Some disks may be divided up into several chunks, okay? Or you can create a volume. A volume can be actually multiple disks. Okay, it's more like a virtual thing you're looking at as a whole. We looked at the example, if you had a disk that had a bunch of platters, a cylinder would be the same track all the way through those platters. If you have read-write heads moving in and out, a lot of times similar data would be stored on a cylinder, so the read-write heads would not have to move very much. And a cylinder towards the middle of the computer. Okay? We talked a little bit about the example of a grocery store. One last thing. Nowadays, it can be referred to as a disk, but it may be a flash drive. And we would refer to that as a disk. So that's created even more interesting ways that we approach file systems. Last thing now. All right. Here, we're just making a reference. We talked about encryption and hashing. We gave the example here of how we use encryption and hashing for confidentiality and integrity between the computers. And then here we talked about how to do that between two Linux boxes. And so, where this relates to the crontab, you can schedule an event, for example, like backup, by creating a script to perform the backup and then using crontab to schedule it, and using this whole idea of setting up the security between the two machines so the machines can back up at the middle of the night and not need a password. That is it.